let's look at the following function. So the following function tells us that x squared plus 2. Now what's useful with these type of equations is that we always want to sort of sketch them. Sketching equations is always a good idea. Or you can use applications like Desmos or GeoGebra to solve these or to graph these type of functions. Now in this case, I have a simple parabola with a vertical shift of 2, which means the function is going to go up and up, both sides symmetrical, meaning they're duplicates, right? What's happening on the right side is happening on the left side, quadrant 1 and quadrant 2. So we want to find the area in this region underneath this curve. Well, in the previous video, we spoke about how to find the area of geometrical shapes or known shapes. But what do we do now? Well, now we want to use some integration. So this is known as a integral. So with the integral, I'm going to simply place the function in front, plus 2, and I will add dx. So what I'm going to do is I'm going to add these points 1 and 3. Now all of a sudden it becomes a definite integral. Okay. With my max input and my lowest input. So how can I define this now? How do I find the integral of x squared plus 2? Well, to do this, we need to be familiar with a little technique. Okay, the technique to solve these type of integrals is x n plus 1 over n plus 1. And to put it very simple, you're just going to add 1 to the exponent and place that as the denominator. Okay, just to make it very, very simple. So let's do that. I'm going to do the entire calculation. So it will look like this. X 2 plus 1. I'm going to take this value down to plus 1. And I'm going to add this to x. Remember, in this case, we currently have x to the power of 0. X to the power of 0 as an exponential rule tells me that anything to the power of 0 is 1. So currently I have x 0 plus 1 over 0 plus 1. And we're going to add a c. Why? Because the derivative of c is equal to 0. So now I want to find the antiderivative of 0. What would that be? It would be c. And we're going to evaluate this function at 3 and 1. So let me just solve this one quick. Over 3 plus 2x plus c over 3, and evaluate this at 0.3 and 1. Now, you don't need to write all of this that I did in this box. I simply did that for the video. So let's continue. Well, what do we do now? Since we have this 3 and this 1 on the right hand side with this weird little line, what do we do? Well, you need to be familiar with the top and bottom function. And to solve this, I can evaluate the function at b, meaning if this value is 3, I can simply substitute my x as 3. Because remember, evaluation just simply means, let's say I want to evaluate when x is 2. That just means 2 squared. Okay, this is the process of evaluation. So I'm going to evaluate my top function and my bottom function. So let's do that. Again, I'm going to write every single thing, since I think it might not be valued to you, but it might be valued to another user or another viewer. So let's evaluate. So I evaluate my top function, which is 3, and I'm going to subtract this from my bottom function, which is 1. So 1 to the power of 3 over 3 plus 2 multiply 1. So I get 27 over 3 plus 6 in my first square brackets. My second square brackets, I have 2 and 1/3. Okay. Let's continue this equation. Again, you can feel free to skip all of these steps. I would recommend for practice sake, just practice all the steps anyway. So we have 9 plus 6 minus 2/3. That gives me 15 minus 2 and 1/3. And then since I'm working with area, I always want, in this case, no measurement is given. So we have unit squared. So I'm going to quickly type this in on the calculator. What the hell? Okay. Hold up, ladies and gentlemen. So on the calculator, it's a little bit tricky. So what I'm going to do is I'm going to take 2 multiply 3 plus 1. Right? That gives me 7/3. So I'm going to subtract it from 7/3. So let's do 15 minus 7/3. That gives me 38/3. So we can leave the answer in this form. So the area underneath this curve is 38/3. Let's go back. This area. Okay? That's what we just calculated. The area underneath this curve. Now this question might be presented a little bit different. It might be presented as follow. The f of x is equal to x squared plus 2. And we might have to evaluate this in the interval of 1 and 3. We're just going to follow the same principle. Now my equation seems extremely long, but this is... Oh! Sorry about that. My equation seems extremely long, but this is pretty much just to show every single step of my work. Now there's some steps we can skip. What can we skip? Let's see. Well, I can skip this step. I can skip this step. I can also skip this step. We can simply define our answer after we've shown our work, right? If we show our work that we're subtracting the two functions, the top function from the bottom function, we're okay. The educator that's marking your examination should know exactly what's happening. Also, we can skip all of this as well. We want to present it as follow. But for practice sake, let's start by doing this. A couple of equations, and then we proceed to skipping steps. All right. Good luck with integration. More videos will follow that becomes more complicated, and we'll look at some theorems while we're at it. Okay, bye.